One of the things we keep hearing across the state is that schools are less interested in a textbook and would like to know what other options are out there. We'd like to show you what the difference is at Lab Aids.
It's important to note that not all publishers are the same. We can be put into two groups. Traditional publishers are publishers who collect age-appropriate content and put it all together as one resource. And then there are publishers who partner with evidence-based program developers who publish a cohesive program developed by one group, often associated with an academic or research institute. Lab Aids falls into the second group. We publish exclusively for CPUP, an acronym for Science Education for Public Understanding program, located at the Lawrence Hall of Science at the University of California in Berkeley. There are a handful of these developers out there, often called reform-based or research-based. These programs are developed using the evidence from respected studies on best practice in science education. Since these programs are developed using the same research, you'll notice that, though there are important variations, almost all research-based programs are inquiry-based, hands-on, embed the content into the activities, group-focused with systems for individual accountability, and student-centered. Lab Aids partners with CPUP to publish their print material and produce program equipment. CPUP uses funding from the NSF to research, develop, and field test its middle school programs, Issues in Science. Issues in Science has just been recognized by Change the Equation as one of the nation's most effective STEM learning programs. It has been awarded the highest rating as an accomplished program. CPUP is unique among the research-based programs as the only one who centralizes each unit on a socio-science issue, hence the title, Issues in Science. All of the curriculum materials put the science content in the context of personal and societal issues. Some examples are, is the growth of Sunbeam City affecting its weather, atmosphere, and water availability? What can the introduction of a new species do to an ecosystem? How can we reduce the risks of a car accident? The issues create the storyline so that the phenomena, the performance expectations, and the three dimensions are connected, relevant, and meaningful. In this investigation, students are gathering data around erosion and deposition in order to decide where to put a new housing development. Students create arguments from evidence they collected to guide their decision.
Students access the CPUP Middle School program through the use of a student book. Depending on how your school is set up, there are a couple of different options. If your school uses a disciplinary program, meaning you teach only Earth, Life, or Physical in 1 year, then you would want the discipline-bound book with all the units for that discipline in one place. If, however, you teach an interdisciplinary or a coordinated program, then the individual unit books are a better option so that you can mix and match the Earth, Life, and Physical based on your scope and sequence. Now, while the student book looks a lot like a textbook on the outside, on the inside it's really quite different. Let's take a look.
Each activity is broken up into 5 parts. The introduction provides background information and connects the daily lesson to the storyline. The challenge question engages the students and provides an objective for the lesson. The procedure then guides the students to discover the concepts for themselves and to regularly engage in the science and engineering practices. The analysis questions then encourage students to process and synthesize the new information to make deeper connections to the learning. These 5 parts repeat in each of the 9 different activity types and are designed to give students increasing independence as they move through the unit. The students become familiar with this system, allowing a space to take ownership of their own learning. Though each activity is designed to be student-centered, the use of the student notebook is really where genuine ownership of the learning takes place. In a CPUP classroom, students use the notebook to track data, record questions as they come up, and build science writing skills. The notebook is a place for both formal and informal writing. Students can brainstorm and create drafts in their notebook and make adjustments to their ideas as new understandings develop. Unlike a traditional textbook, the activities, the equipment, and the student notebook are all components of an intentionally integrated program. Take one of these components away and it would be immediately obvious that something is missing. Behind the scenes, professional development, teacher resources, and teacher additions are also completely integrated so the teacher knows exactly how to best guide the classroom. To give you an example of the seamless component integration, let's look at the literacy supports in the teacher resources, the student book, and the activities in a CPUP classroom. The CPUP curriculum helps students develop language literacy through informational texts and procedures, writing clearly through analysis questions, designing investigation activities, and science notebook entries, and practicing their oral skills through discussions, debates, and presentations. The literacy strategies are easy for teachers to use as they are embedded in each activity. A list of all strategies offered and their corresponding activity are found in the teacher resource book. With experience and practice, CPUP teachers customize for their students by placing heavier focus on the most needed strategies. Teachers also use the CPUP resources to differentiate beyond literacy strategies to meet unique classroom needs. Because CPUP is developed from research on best practices, differentiation is already a natural part of the design. To meet different learning modalities and deliver the content in multiple ways, CPUP uses 9 instructional methods. Additionally, all activities use the CPUP 4-2-1 cooperative learning model. Students work in groups of 4s or 2 pairs to conduct experiments and solve problems, while each student is accountable for recording data and observations. Because of this model, all equipment comes prepared for 16 pairs or 8 groups of 4.
Materials are incredibly organized to help you manage an inquiry-based and hands-on classroom. To prepare for a day, you look in the teacher edition at the material and advanced preparation list. That tells you exactly what you need to do to set up and what materials you need for that particular activity. All the materials are included and organized in drawers with individual compartments for each item. This is set up to also support the 4-2-1 cooperative group model, and it helps manage materials so that you know right away if something is missing.
At Lab Aids, we often joke that the supports in the CPUP system are so seamlessly embedded that they're almost invisible. This is intentional for the perspective of a student, but as a reviewer, it's easy to overlook these valuable features. Like the inquiry-driven design and the differentiation supports, assessment is also embedded. When you start your review, be sure to look for these components of the assessment system. The 9 assessment variables define the content and practices that students are expected to learn. Assessment questions, or tasks, are embedded throughout the program and are used to gather evidence about student understanding and skill levels. The 9 scoring guides match the variables and are used for teachers to closely monitor students' growth and encourage their progression from novice to expert on each variable. Here, embedded in the student's analysis questions is an assessment opportunity for the variable evidence and trade-offs. If the teacher chooses to formally evaluate the student on this question, the rubric for evidence and trade-offs may be used. The assessment system also includes overviews for planning, exemplars, item banks for tests and quizzes, and quick checks for informal assessment. To support professional development and provide ongoing training, purchase of the program includes comprehensive tutorial videos for select unit activities. These cover an overview of the entire unit, followed by a detailed section on the components of one lesson in the teacher edition. This includes how to get started, how to do the lesson with supports for literacy and differentiation, and how to close the lesson with optional assessment. Another favorite program feature is our LabSync videos, which you see snippets of here. These support teachers and students during absences. Every lesson has an activity specifically modified for use outside the classroom and includes a simple video if it's appropriate. This way, students may return to class with data, observations, and analysis in their notebooks and be largely caught up with the rest of the class when they return. For more information on these and other teacher resources, go to labaids.com/resources.
Typically in the review process, schools first get a feel for what's out there, like you're doing now, and then start to narrow programs down based on a best fit for teaching philosophy and student needs. If you're excited about the Lab Aids and CPUP Middle School program, we'd like to set you up with a workshop so that you can experience the program firsthand. It's also a great introduction to our exemplary professional development. Our professional development trainings are like our programs, engaging, hands-on, and personally relevant. Workshops and implementation days are taught by current CPUP teachers who are uniquely qualified to support schools new to the CPUP program. We consistently see that schools who thoughtfully incorporate professional development into their adoption plan are able to significantly accelerate the implementation process. Setting up a workshop can help to review the program, but can also be a great jumpstart on professional development should you choose to purchase. Recently, at a professional development event, we asked several teachers why they teach with Lab Aids.
Hi, my name is Judy Steer and I teach in West Bend, Wisconsin. I teach with Lab Aids because of the science inquiry-based methods. I know that CPUP uses the best, most effective programs, and it takes all the guesswork out of teaching so that I can focus in on with my kids and be the best science teacher I can be.
And I teach with Lab Aids because I really enjoy the real-world examples and the inquiry-based design of the curriculum. I think the students respond much better to this than a traditional science curriculum. They've come to me years afterwards and told me they really enjoyed it, or they're excited to see the things that we talked about in the news.
Hi, I'm Lisa Martin Hansen. I'm at Cal State Long Beach. I've been teaching with Lab Aids because it's hands-on, it's engaging, and it helps our students to see some good modeling of NGSS practices.
Hi, I'm Bill Gippridge from Edmond, Oklahoma, and I teach with Lab Aids because I've seen the difference it makes with my kids. They're using inquiry science. I was always a believer, but once I started using Lab Aids, I realized it allowed me to do things better than I could ever do by myself.
My name's Cindy Lilly and I'm from Myrtle Beach, South Carolina. I teach with Lab Aids because first, it makes me a better teacher, and second, it's able to reach a diverse group of students and address all my learning needs. And that's why I teach with Lab Aids.
John Allen, your Lab Aids Science Curriculum Coordinator for New York City, will be the one to get you set up. Lab Aids is an employee-owned publisher with a dedicated staff committed to providing a comprehensive and meaningful science experience for all students. We hope you'll join us.